In this video, we're going to be learning how to balance chemical equations. First thing you want to do in balancing chemical equations is you want to list the atoms or the elements that you have in the chemical reaction. And so in a chemical reaction, the reactants are always written on the left-hand side of the arrow. So here's your arrow. And then the products, which are the substances that you're producing or you're making in the chemical reaction, are written on the right of the arrow. And this arrow means to make, to produce. And so the way I think about it is if you go to the produce section, you buy produce, you buy a product, you buy something that someone had to make. And so your starting ingredients are always on the left-hand side of your chemical equation. Your products are always on the right-hand side. And so the first thing you want to do is you want to list those elements down the middle of the reaction. I always put them right underneath the arrow so we can see them, and then we can tally up each side. So we have carbon on the left here, and then we don't want to write O2, we want to write the elements that we have, and so oxygen is the other element that we have. You'll notice we don't have any other elements on the reactant side, just carbon and oxygen, and on the product side we have carbon and oxygen. So we're going to make our initial count at this point. So we have one carbon on the left. On the product side, we have one carbon. On the reactant side, we have 2 oxygens. And then on the product side, we have 1 oxygen. And so you can see that we are unbalanced. It looks like we went from 2 oxygen atoms to 1. And the law of conservation of matter states that matter cannot be created or destroyed. It only changes forms. And so if we have 2 oxygen atoms to start, we have to have 2 in the end. So we're going to balance this chemical equation to represent what would happen if the reaction proceeded in real life. And so we're going to go balance the oxygen. The way we do that, we cannot change the subscript and make it look like CO2. CO2 is carbon dioxide, but what we have in the formula is carbon monoxide, which is a poisonous gas, and is very different than carbon dioxide. So we want to make sure that we don't change these subscripts. And so, another example of this is H2O, right? So this little 2, we call it a subscript. And you can't change the subscript in a chemical formula. And so the reason we know that is based on the way formulas are written is if we changed this we changed it to a 2, it was H2O2, this wouldn't be water anymore. This would be hydrogen peroxide. And then up here, H2O, we know is water. And so it's really important that we don't change the subscript, the small numbers below the atoms. So we're going to keep CO the same. We're just going to manipulate the coefficient. So what is a coefficient? A coefficient is the number that you place in front of the molecule. So if I put a 10 here, that means I have 10 water molecules. And this is a distributive property. So 10 times 2 means I have 20 hydrogen atoms. And then 10 times, there's not a subscript written here, so we assume it's a 1. We don't write 1s in chemistry usually. So 10 times 1 is 10, and so we have 10 oxygen atoms. And so we have 30 total atoms if we have 10 water molecules. So using this concept, we're going to do the same thing for the equation we're balancing. So in order to get 2 oxygens on the product side, we got to put a 2 here. 2 times 1 carbon is 2 carbons. 2 times 1 oxygen is 2 oxygens. So we originally wanted to make the oxygens 2, which we did, but at the same time we manipulated the carbons. We have to, because the carbon and the oxygen are bonded together. So for every 1 oxygen, there's 1 carbon. So if you have another oxygen, you'd have to have another carbon. So nothing we can do about that. You can't split this molecule apart. So now we want to go back over here to the left-hand side, and we realize we only have 1 carbon here. So in order to get 2 carbons, we're going to put 2 in front of that carbon. And then we cross out the 1 and we update our count to a 2. So the balanced chemical equation here, everything is balanced at this point. So the coefficients are 2. We didn't change this, so it's a 1 there and a 2. So 2, 1, 2 are our balanced coefficients. So we call this the numbers in front of the element or in front of the compound or molecule, we call the coefficients. So let's go to number 2. So kind of write our elements down the center again. So we got magnesium, Mg. We got copper. And I like this sulfate, SO4, I like to balance that as one thing because it's called a sulfate ion. So it's always going to come together like that. And so we're going to keep it together. So magnesium, there's 1 on the reactant side. On the magnesiums on the right, there's 1. Copper on the reactant side, there's 1. Copper on the product side, there's 1. Sulfate, there's 1 SO4 on the left, reactant side, and then there's 1 SO4 on the product side. So this is already balanced and we don't need to change anything. And the coefficients are 1, 1, 1, and 1. All right, so let's go down to this next one. So our elements are Cu, O, and carbon. So start with copper. There's 1 copper on the left, 1 copper on the right on the product side. Oxygens, there's 1. Oxygens on the product side is 2. Got that O2 right there. The 2 is only for the oxygen. The carbon doesn't have a 2. It has a 1. If you don't see a subscript, you assume it's a 1. And then carbons on the reactant side is 1. Carbons on the product side is 1. So we know we got to balance our oxygens. So we're going to go to our left side here. We're going to put a 2 in the front. 2 times 1 oxygen is 2. We also changed our copper, so we have to recount those. So 2 times 1 copper is 2 coppers. And then now we know our coppers are unbalanced. So we're going to have to put a 2 here in front of the copper. 2 times 1 copper is 2. So our coppers are balanced, our oxygens are balanced, and our carbons are balanced. So this balanced equation is 2, 1, 2, 1. Let's go to this next one, number 4. So all we have here is oxygen. This makes it nice and easy for us there. There's 3 oxygens on the reactant side, 2 on the product side. So the way I think about this is 3 and 2 are not going to, it's not easy to, what number can I multiply them both by so that they're even? So I can multiply 3 times 2 to get to 6. I can multiply this 2 over here times 3 for a coefficient to get to 6. And so now it's balanced that way. So the coefficients are 2, 3. for the balanced equation. All right, so let's move down to 5, get a little more involved here. So we have copper, we have silver, and then this NO3 is a polyatomic ion. We'll learn more about that in a different video. We'll bounce the NO3 together as one unit. So we got one copper on the product side, one silver on the reactant side, one Ag on the product side. NO3, there's one of them on the reactant side. Now here you have NO3, and then you see these parentheses right here. So when you have the parentheses and you have a 2 on the outside, this is distributive property. So what this is showing is that you have NO3, but you have it twice. So if you look at these two NO3s at a row, you can see O3 and O3 would be 6 oxygens and then 2 Ns overall. So if I just look at it here, when I do distributive property, 2 times 1 or 3 oxygens is 6 oxygens, and then 1 nitrogen times 2 is 2 nitrogens. So this here is the same as the way it's written here. So we got 2 NO3s, and then we have our 1 silver over there. So we know that NO3s are unbalanced, so we put a 2 in front of this, so that we multiply that by the whole NO3. So that gives us 2 NO3s. And that turns our silvers to 2 now instead of 1. And so then what we can do is just go back over here to the right, turn this into a 2. Now we'll balance our silvers. So the balance equation has coefficients of 1, 2, 1, and 2. All right, so we're getting a little more involved here. This number 6 is a little challenging. It's called a combustion reaction. Anytime you burn a hydrocarbon with oxygen. So hydrogen, hydro, carbon. You always get CO2 and water as a product when you burn the carbon-based fuel. So we have carbon, oxygen, hydrogen. Now here in this scenario, I'm going to show you a little shortcut here when you have a combustion reaction. So we'll write it combustion. So combustion is just a special type of reaction where you burn a hydrocarbon to make CO2 and water. So anytime I have oxygen and hydrogen in my balanced equation or in my chemical reaction, I always want to balance oxygen and hydrogen last. And the reason for that is oxygen and hydrogen can be in multiple compounds. So you see oxygen in the CO2 and you see oxygen in the water. And so it just makes it more challenging to balance those. Now the trick for combustion reactions is to balance carbon and hydrogen and then do oxygen last. So on the left hand side we have 8 carbons, C8, we have 2 oxygens, and we have 18 hydrogens. Then on the right product side we have 1 carbon and we have 3 oxygens, O2 plus this oxygen, which is a 1 right there. And we don't really write 1s in chemistry. So 3 oxygens. Then hydrogen is 2. H2. So we're going to balance the carbons first. I'm going to put 8 right there to make 8 carbons. And then 8 times 2 makes me 16 oxygens. plus this 1 in the water. So 17 oxygens. And then I want to get my hydrogens balanced so I can do a shortcut to get the rest of it balanced. So hydrogen's got to be 9. 9 times 2 is 18. My oxygens are 9 times the 1 oxygen is 9 oxygens plus these 16. So 16 and 9 is going to be 25 oxygens. So at this point, my hydrogens are balanced and my carbons are balanced. So a little shortcut here is to, we'll first look at the oxygens. And so it's O2 on this left side. So it's like, what number can I multiply the O2 by to get to 25, which is what I have on the product side. And so it's not going to work out. 12 times 2 is 24. 13 times 2 is 26. So the shortcut here is to multiply the whole reaction by 2, but just don't put anything in for the oxygen. Don't multiply the oxygen by 2, but everything else by 2. So when we multiply everything by 2, you have 2 times the 8 carbons, 16 carbons, and then 18 times 2 for the hydrogen is 36. And then 2 times the 8 CO2s turns this into a 16 for the coefficient. 16 times 1 carbon, 16. And then 16 times 2 oxygens is 32, plus these 9 over here. Gives you 41. And then when you look at how to balance this, the hydrogens need to get up to 36. So we got to multiply what times H2O will give you 36. It's got to be 18 here. 18 times 2 hydrogens gives me 36 hydrogens. And then I want to recount my oxygens. And so 16 times 2 oxygens is 32 with the CO2, plus the 18 oxygens here. So 32 and 18 is 50 oxygens. So then my hydrogens are balanced, my carbons are balanced, and my oxygens are not. So then I got to ask myself, what number, where this X is, where I said don't put anything in for the oxygen, right? What number times O2 is going to give me 50. And so in this case, this would have to be a 25. 25 times 2 is 50 oxygens. So everything's balanced at this point. The coefficients are 2, 25, 16, and 18 for the balanced chemical equation. All right, let's look at these last two. All right, last two. I got like a few more here, but we'll do a couple more here. So number 7. All right, so we have tin, we have hydrogen, and we have fluorine. So tin on the left, reactant side is 1, tin on the right is 1. Hydrogen on the reactant side is 1. Hydrogen, we have this H2 here, so that'll be 2 hydrogens. Fluorine on the reactant side, 1. Fluorine on the product side, 2. So we need to get the hydrogens up to 2, so we multiply this by 2. And that gives us 2 hydrogens now and 2 fluorines. And everything else here is balanced on both sides. So our coefficients are 1, 2, 1, 1. All right, number 8, aluminum hydroxide. So let's do aluminum. Let's do the OH3 together. Actually, let's not do that because the hydroxide doesn't stay as hydroxide. So let's just go oxygen, hydrogen, and chlorine. So aluminum is 1 on the reactant side, 1 on the products. Oxygens are 3 times 1 oxygen here is 3 oxygens, and that's distributive property for the hydrogen as well. So 3 hydrogens. Chlorines are 1 chlorine on the reactant side, 3 on the product side. Hydrogens, 2 on the product side. And then oxygens, 1 oxygen. So we always want to do hydrogen and oxygen last. So I'm going to go after chlorine. So we'll need to put a 3 here to get 3 chlorines. And then 3 times 1 hydrogen is 3 hydrogens plus the H3 in the aluminum hydroxide. So that's 6. And then we're going to go after oxygen here since everything else is balanced except for oxygen and hydrogen. So to get oxygen to 3, we got to turn this 3 times H2O to get 3 oxygens. That also changes our hydrogens to 3 times 2, which is 6. And that actually helps out and balances everybody. So our coefficients are 1, 3, 1, 3. All right, moving on to number 9. This one's a little bit more involved. So it's calcium, phosphorus. Now what I'm gonna do again here, you saw that, kind of decided to go back, is I'm going to do phosphate, the PO4. Phosphate ion together is 1 because it's on both sides. And then I'm going to do the sulfate ion, SO4 together. Then I'll do hydrogen last. So calcium, there's 3 on the reactant side, 1 calcium here. Phosphates, there's PO4, but there's 2 of them. Then phosphates here, there's 1 phosphate ion. Sulfate, SO4, there's 1. Sulfate, there's 1 on the right. Hydrogens, there's 2 hydrogens right here, H2. And then on the right side, there's H3. So let's balance our calciums first. Put a 3 here. Get this to calcium to be a 3. That makes our sulfates, our SO4 group, makes 3 of them. And then we got to get our phosphates up to 2 on the right. So we're going to put 2 in front. 2 times 1 PO4 is 2 of them. That changes our hydrogens to 3 times 2 is 6. And then our sulfates on the left. There's only 1 sulfate. We need 3. So 3 times 1 sulfate is 3. But our hydrogens are now 3 times 2, which is 6. So everything's balanced there. So it's 1, 3, 2, 3 to get the balanced equation. So we have nitrogen, we have oxygen, we have hydrogen. Okay, so nitrogen's on the reactant side is 1, nitrogen's on the product side is 1, oxygen's on the reactant side is 2, oxygen's 2 plus this 1 is 3, hydrogen's 3 on the reactant side, hydrogen's 2 on the product side. So we'll take the oxygens up to a 2 here. 2 times 2 is 4, just because we need at least 3 of them. Then on the product side, we need to get the oxygen up to 4. So we'll put a 2 here. 2 times 1 oxygen is 2, plus these 2 here is 4. And then hydrogens, we have to recount those. That's 4 hydrogens on the right side. And then we got to go back over here to the hydrogen side. We got to get this to a 2 That'll give us 2 times 3 is 6 hydrogens, but then our nitrogens are now 2. Then we're going to go back up to nitrogen to get it balanced. We put a 2 here, makes 2 nitrogens, but we recount the oxygens. 2 times 2 oxygens is 4 oxygens, plus these 2 over here in the water, that's 6 oxygens. And then, so we need to get our oxygens balanced. So we're going to go back over here, and we're going to turn this into, let's cross this out right here. Put this, get this a 3. 3 times 2 oxygens is 6. So those are balanced. Hydrogens on the product side, got to get up to 6. So we're going to cross this out. Do a 3. 3 times 2 hydrogens is 6. But then that messes up our oxygen. So 3 times 1 oxygen is 3. Plus the 4 oxygens in NO2 is 7 oxygens. And then that, yes, our oxygens on the reactant side are 1 short, so we got to make this a 4. So 4 times 2 oxygens is 8. So we got to go back to the right, and oxygens are at 7. So we're going to make this a 4. So 4 plus these 4 is 8. So those are balanced. But our hydrogens go 4 times 2 is 8. So then our hydrogens on the left side are at 6. So we got to turn this into a 3. 3 times 3 hydrogens is 9. But our nitrogens have to be recounted. 3 times 1 nitrogen is 3. And then that means we have to recount our nitrogens on the right, or we have to change the coefficient on the right to get it to 3. So cross this out. So 3 times 1 nitrogen is 3. Plus 3 times 2 oxygens is 6. Plus these 4. So that's 10. And then we need to go back to the left to get our oxygens up to 10. So we're going to cross this out, make it a 5. 5 times 2 oxygens is 10. But our hydrogens are 1 short on the product side. So we got to change this 4 to a 5. 5 times 1 oxygen is 5. Plus 3 times 2 is 6, which is 11 for the oxygens. And our hydrogens are at 10. So we got to go back over here to the oxygen side. Make this a 6. 6 times 2 is 12. And then we got to get our oxygen on the right to 12. So we got to multiply this by a 6. 6 times, let me clean this up a little bit. It's getting a little bit messy. Yeah, let's clean this up a little bit. It's getting a little bit crazy. So it's a 6 right here. Right? This is a 6. And then this is a 3. And then let's get this to be a 6 too before we get out of hand. So the 6 right there. I just made a lot of changes in this one. All right, so just real check these again. Oxygen is at 6 on the right plus 6 in the NO2 there. That's 12 oxygens. And then the hydrogens, 6 times 2 hydrogens is 12. So our oxygens are good on both sides. Let's go to hydrogen. We got to multiply this 3 times a 4. To get 4 times 3 hydrogens is 12. And then our nitrogens are at 4 now. So 4 nitrogen. So we got to take this 3 to a 4 to get 4 nitrogens on the right. We got to recount our oxygens. 4 times 2 oxygens is 8. Plus these 6 is 14. And then we got to turn this to a 7. 7 times 2 is 14. That was a long one. You can see just kind of, that's why I love having the elements down the middle, because I can go back and forth and make changes and still keep track of my count.